Hi, my name is Yakov. This is The Swift Bird, a channel where I explore the world of tech, software development, and bird development. But let's leave the bird part for a future video and focus on software for now. This is the first part of a series I called Intro to iOS App Development. In the series, I'll show you how to start from scratch and learn the most important things a beginning iOS app developer should know. Subscribe to the Swift Bird so you don't miss the next episodes. And if you're watching this video at a later point, they may already be available on the playlist. Besides, I have stuff for more seasoned developers that's also worth subscribing to. Before we begin, I have a short message from my sponsor, which is you, potentially. As you may have noticed, the Swift Bird is a very small channel run just by me. However, I'm not ready to compromise in quality, which means production takes a lot of effort. Sometimes I spend an entire night to edit a video, and to do that I need a lot of coffee. You can support me by buying me a cup or becoming a regular sponsor. You'll find the links in the description. Now back to the video. Over the next few minutes, I'll be talking about what this series is, who it is for, who I am, and how I ended up starting a series like this. You may be tempted to skip this part, and I'll even put the timecode somewhere on the screen. But I suggest a better plan. While you're watching this intro to an intro part, go start downloading Xcode. It's the main tool for building iOS apps, and you'll need it later today. The file is about 8 gigs in size, so while it's downloading, I can tell you a few things. I'm a professional software engineer. I mostly work with iOS, though lately I've been exploring Mac development as well. I started over 5 years ago, when the iPhone still had a home button, and since then I've worked on projects with millions monthly active users. I also work on a few projects of my own. By the way, one of them brought me a trip to WWDC paid for by Apple. I started doing software development completely on my own, and partly by coincidence. I was in college studying international business, and some of the courses in my sophomore year were so boring and useless I felt bad for wasting my time on them. So I found myself a better business. That's not to say I'd never thought of software development before. I had been interested in it prior to that point, but never had enough time or motivation or something else. So that disappointment in my university courses was the momentum I needed. It took me about 3 months to create a project I was satisfied with and could put on the App Store and show others, plus a couple more months to land a job. Of course, I continued learning new stuff both at work and on my own time, and there was a lot I still needed to learn. That's the story of how I got into development. But there's one more about how I got into teaching development. A company I worked for, a bank, ran a biannual course on iOS app development. It was taught by the company's own engineers, mostly in senior roles, and I was one of them. The course was completely free for students, and anyone could apply. Those seats were limited, and we could enroll only 10 to 15% of applicants. When I was approached about joining the lecturers, I got really skeptical at first. It was like, me? Teaching others? But since the course lasted for only 3 or 4 months, my skepticism eventually gave way to interest. Why not, I thought. It's just another work project. But I gotta say, this project was one of the most exciting parts of my work at the company. I hadn't realized interacting with students could be so energizing. And that brings me to this YouTube series. I thought if I can do something that I enjoy while also helping others, it's a great opportunity that I don't want to miss. So in this and future videos, I'll be showing and explaining the most important concepts of iOS app development, which can help you get started in the industry. It's an intro series, but that doesn't mean it's basic. As I mentioned, I used to teach a similar course at work, and our goal was not to just entertain the students, but to actually hire the best graduates. So I'll be showing the very practical things needed to develop apps, including the Swift language, building the user interface, memory management, networking, automated testing, software architecture, and more. I'll do my best to keep them easy to understand, but your feedback is always welcome in the comments. Over the course of this series, I'll be continuously working on a single project, starting from scratch, building it step by step, and explaining every aspect in the process. The project is a fairly simple app where you can apply different filters to a photo. I chose this idea because on the one hand, it allows me to demonstrate many of the concepts used in real apps, while on the other, it doesn't involve things that are so niche you can't reuse them in other projects. In this app, I'll be using UIKit as the main user interface framework. The reason for choosing UIKit over SwiftUI is purely practical. So far, I haven't seen any serious projects which use SwiftUI exclusively, and I don't believe it'll suddenly change tomorrow. Plus, for my personal taste, SwiftUI is still not quite ready for heavy production use. Yeah, even after 4 years since its release. I was there at Machinery when SwiftUI was introduced, and despite the enormous attention SwiftUI was getting, I'd say Apple has overpromised and underdelivered. But that doesn't mean I'll be ignoring SwiftUI altogether. To develop iOS apps, all you need is a Mac computer. Though the Swift language itself does support other operating systems, the iOS-specific frameworks and tools are macOS only. It's helpful to have an iPhone or iPad to test the app on a real device, but that's totally optional because Xcode comes with a simulator, basically a virtual iPhone. I have one last introductory thing to say, but that thing is important. This series will be helpful if you're truly interested in software development, ready to take your first steps and just need some guidance. In that case, I'll do my best to give you the most efficient shortcuts. But I advise that first you listen to yourself and check your motivation. If you see software development as just a fancy, sexy and well-paid thing that doesn't require much of you, you'll regret the wasted effort, because it does require much. Much time, much focus, and much self-discipline. I had spent hundreds of hours learning, trying, and failing without any guarantee of success. But I was enjoying the process. The process of creating new things that haven't existed before. And I still enjoy it now, even when I'm working on my own projects. Especially when I'm working on my own projects. I'm not paid for them, but I get to do whatever I want. And I love it. So, if you think software engineering is cool just because of big salaries, better spend the time looking for your thing. Don't stop searching until something clicks. That is my advice to you. It's just that I've witnessed people look at their developer friends and think, oh, they're paid so well, I can do it too. And a couple of times I was that friend. Of course you can do it too. Software engineering isn't something that requires a natural talent or whatever. But you'd very likely suffer from doing the thing that you don't really enjoy. I guess we're done with the introductory part. And I also hope that Xcode you were downloading is ready to use, because we'll need it very soon. I mean, right now. Xcode is a fairly typical IDE. It combines a code editor, UI composer, compiler, debugger, and other tools which you need to build, test, and monitor the app. There are other IDEs for creating iOS apps as well, but they still use some of Xcode's components in the end. Xcode is sometimes criticized for being slow and buggy, and you may have noticed the low rating on the App Store. But personally, Xcode has always been fine to me. I can't remember any major problems in the 5+ years I've been using it. It's important to understand that Xcode is a very big, very old, and very versatile tool. Think of a Swiss Army knife, except Xcode gains new features every year and at the same time supports compatibility with ancient projects. I told about one of them in a previous video. When you develop an app, you do so in an Xcode project. In a nutshell, projects are simply collections of individual files. Often these are files with source code or source files, but not only them. Projects can also include UI components, resources, and settings. You can include any file in the project, even if it's not needed in the app, but I recommend keeping projects free of unneeded stuff. Xcode projects often consist of multiple targets. A target is basically an independent piece of the whole theme you're working on. Each target has some output, which you get when you build it. That output is called a product in Xcode, so you get a one-to-one relationship. One target equals one product. An app itself is represented by target 2, and one target can depend on others. For example, your project may have a target for the iPhone app, target for the Mac app, target for a framework used in both apps, and another targets with tests. I'll have separate episodes about app architecture and automated testing, so subscribe to the channel if you don't want to miss them. For now, a single target is enough for the app I'll be creating. Let's go ahead and create the project. When you launch Xcode, you're presented with a welcome window, which lets you quickly make a new project. After that, you're offered a large number of templates. As I mentioned, Xcode supports many scenarios, from normal apps to low-level things such as device drivers, to iMessage stickers, where you just drag and drop images without writing any code. I'll use the regular iOS app template. On the next screen, Xcode asks for some basic details. Of course, you can change them later. For the product name, I'll use Filterbird. It's okay to use white spaces, but keep in mind that they'll be converted to hyphens in some places and underscores in others. I personally don't like that sort of inconsistency, so I omit the spaces. You can leave the theme set to none. To set it, you need a developer account. You can create one for free, and it's a nice thing because it gives you some additional features, such as the ability to run the app on a real device. But the account isn't really required until you want to publish the app on the App Store, so you can save time. The bundle ID is how the operating system differentiates apps. Separate copies with the same bundle ID are considered to be the same app, and vice versa. It's best to not change the bundle ID once it's set, but unless your app's already published on the App Store, it is possible to do so. The first part of the bundle ID is the organization prefix. I'll be using com.example because, well, it's an example app. Usually, this part contains the company's name or website in what's called the reverse domain name notation. For example, com.apple or org.swift. It makes it easier to group together apps from the same developer. Interface and language are the two important pieces at this step. I'll set up the project with storyboards and not SwiftUI. That doesn't mean I can't use SwiftUI later in the process. That only affects the app's lifecycle management system. In language, I can choose between Swift and Objective-C. I'll obviously choose Swift. I'll leave tests and core data unchecked because I don't need them right now. And when tests are needed in the future, I'll add them separately. Once I've made all my choices, I click Next and can choose a location for my project. The location isn't really important, you can choose any folder, but I'd like to highlight the Create Git repository checkmark. I advise that you always check it. In case you never worked with Git before, it's a version control system, which means that every change you make in the project is tracked in its history and can be reverted in the future. Git can do many more things than that, but I won't go into much detail right now. Let me know in the comments whether you need a separate video about Git. Now the project is created, and what you see is the main Xcode window. It's logically divided into 4, I'd even say 4.5 parts. What I mean, you'll see in a second. You have the navigator's pane on the left, which lets you browse the project. There's more than one navigator because you have several ways to move around. For example, besides just browsing the files in the project, you can use search, view the symbols defined in the project, or only focus on breakpoints. I'll get back to all of them in a future episode. The largest pane in the middle is the main working area. It's where files open when you select them in the navigator. As you can imagine, this pane's contents change depending on the type of file you're working on. Sometimes it can be a text editor, sometimes an interface constructor, and so on. On the right, you have the inspectors. Which inspectors are available also depends on what kind of file is open. For example, working with the source code lets you browse the related documentation in the inspector, while opening a user interface file allows you to make adjustment to UI elements. On the Windows top, you have the scheme and destination selectors. Schemes are like quick recipes which you use for different purposes. For example, one scheme can be used for building the app during development. In that case, you'll want to skip tests and checks to prioritize performance. And a different scheme can be used for creating a production build for the App Store. That scheme will check every part of the app to make sure it doesn't have hidden bugs. The destination selector lets you choose where you'd like the app to run. It can be a simulator or a real device connected to the Mac. What I meant by 4.5 parts is there's one more pane, which is hidden most of the time. It's used for debugging an app when it's running. I've shown you how to create a project for your iOS app and explained the main tools available in Xcode. For this episode, I have one more topic to cover. It's what's called the app lifecycle. To iOS, each app is represented by a UI application instance. It is the central point of interaction with the operating system. It receives user events such as taps or scrolls and handles them in the way that makes sense for the concrete app. UI application has a couple more responsibilities. For example, opening links in the system web browser or starting background tasks. In most cases, you use the default UI application instance provided by the system. And when you need to customize the app's behavior, you use a helper object called the application delegate. The delegate gets messages about the important events related to the app and then can handle those messages in the most appropriate way. For example, run some code, report the event to another object, or just ignore it. The app delegate can do many things, but its most important role is handling changes in the app's lifecycle. By lifecycle, I mean different states the app can be in. You can see them on the slide, and let's have a closer look at each of them. Initially, the app is not running. It doesn't use any device resources such as memory or processor time, and doesn't run any processes. As soon as you tap the app's icon, iOS opens it and presents the launch screen. It's a static element which doesn't support any kind of user interaction, and that is why the app's considered to be inactive. In the meantime, the system creates the UI application object I mentioned and performs certain startup procedures. Once they are finished and the app is ready to interact with the user, iOS transitions it to the active state. This is the app's main state. While the app is active, the user can tap buttons, scroll lists, switch between tabs, and do everything else. But sometimes an external event occurs. At least it's external to the app. And that event makes the app inactive. The examples are an incoming call, low battery alert, the user opening the control center to adjust screen brightness, and something similar. At that point, the app is still displayed on the screen and can run tasks, but the user cannot interact with it. If the event is dismissed, for example, the call ends, the app becomes active again. That is why you see a double-sided arrow above the inactive state. Apps can switch between the active and inactive states many times within a single session. But if instead of getting back to the app, the user switches to another one, for example by opening a notification in the notification center, the first step goes to background. In that case, the app continues running and using the device's resources, but it's not displayed on the screen. After a while, iOS suspends the app to save battery life. When the app is suspended, it doesn't run any tasks, but still remains in the memory, so it can be restored anytime without losing data. However, if the amount of available memory gets too low, it's called memory pressure. The system stops the app completely, or terminates it, taking back all the resources and putting the app back to the initial state. The next time the app is opened, its lifecycle starts all over again. As I mentioned, the app delegate learns about the changes and can react to them. For example, if the delegate learns that the app is about to be terminated, it's a good opportunity to save the user data so it's not lost. Let's see that in action. Now, before I show you, there's one more thing I should mention. Since iOS 13, apps can natively support multiple windows, also known as scenes. You may have seen this behavior on the iPad, where you can open two Safari windows side by side. That behavior is not relevant for the majority of apps, but Xcode still creates the scene delegate file with each new project. It's virtually the same as the app delegate, and many methods literally overlap each other. The only difference is that you have a separate scene delegate for each app window, while there's always only one app delegate. In single window apps, that can cause confusion, because it's not always clear why some events in the app's lifecycle are reported to the app delegate and others to the scene delegate. If you don't need multiple windows, you can simplify your workflow by deleting the scene delegate. I'll show you how. Of course, you can add it back if you decide to add multi-window support in the future. First of all, delete the scene delegate file. Make sure to select Move to Trash so the file is deleted for real and not just unlinked from the project. Next, open the info.plist file. This file keeps the basic details about your app, such as its name and version, and provides them to the operating system. The info.plist file looks almost blank because in the recent versions of Xcode, most of the records are auto-generated. To get a sense of the file's actual contents, select your project in the navigator and switch to the Info tab. What you need to do here is find the application scene manifest row and delete it with the minus button. You can see that this record has been deleted from the file as well. Finally, you need to make a couple small changes to the actual app delegate to restore its full authority over the app's lifecycle. First, remove the main attribute on the top and type UI application main instead. Xcode will suggest the right autocompletion once you start typing. Second, add the window variable somewhere inside the app delegate, between its opening and closing braces. Again, you'll get a suggestion. And third, remove the code marked with the UI scene session lifecycle heading. Now is a good time to run your app in the simulator. You can use the default device or change it to some different model. Click the Run button and in a few seconds the simulator will appear with your app running. As you can see, the app has launched but it's only shown a white screen. That's not surprising given that we haven't added anything to the user interface. We'll do it in a minute, but before that, I suggest we have a look at the lifecycle events I described. In the app delegate file, you see a method called application did finish launching with options. This method is called when the app has loaded its resources and is ready to transition to the active state. To make it more apparent, I'll add a single statement which will print the name of this method whenever it's called. To print something to the debug console, you use the print function. And to quickly reference the current function, you can use the hashtag function expression. Now, there was only one lifecycle event, but as you can remember, there's more. The methods for them are not required. If you don't want to customize anything, you can just skip them. But you can add them just as easily. To make state transitions as clear as possible, I'll add all of them. So here I have application will enter foreground, application did become active, application will resign active, application did enter background, and finally application will terminate. From the names, specifically the will or did part, you can see whether the method is called shortly before or immediately after the event. In every method, I'll use the same print function statement. Because the hashtag function expression is dynamic, it'll use the correct function name in each case. Let's rebuild and restart the app again and see what we get. The debug area opens and so far I only see the 2 of the 6 methods. But try going to the home screen with the button in the simulator and you'll see 2 more prints appear in the console. Open the app again and another 2 will appear. When you exited to the home screen, the app stopped being active first and then went to background. These events not always happen simultaneously, and you can see it by opening the control center. See, the app has resigned its active state but has not entered background. Finally, if you open the multitasking view and close the app, the last app delegate method will be called. We're done working with the app delegate. But before we go on to the UI, let me show you how to save the changes you've made so far to Git. As I mentioned, Git keeps track of all the changes as the project evolves, and it's a good idea to keep these records, known as commits, small and narrow scoped. In the top menu, click Source Control and select Commit. You'll see the version control window that shows the changes made after the previous commit. Check all the files, add some message, and click Commit. Now is a good time to add something to the UI so it doesn't look that boring. First of all, open the launch screen storyboard. As you can guess, it is the screen displayed while your app is launching, during its inactive state. Click the plus button in the toolbar to open the library of components. We can also open this window with the Shift-Command-L shortcut. Drag the label element to the center of the screen. Then open the Attributes Inspector, which is the 5th tab in the Inspector's pane. Here you can customize the label, enter its text, change the font, and do so much more. As I mentioned before, the launch screen is static, which means you can't use any buttons or other interactive elements. In the actual interface, interactive elements are the center of your app, so let's add a button to the app's main and so far the only screen. This screen is stored in the main storyboard. Drag a button element to the screen and change its title to something that makes sense, such as Open a Photo. Though that button appears on the screen, it doesn't really do anything. But in a future episode, I'll connect this button to the app's code, so when the user taps it, the button does what it says. Restart the app by clicking the Run button again, and this time you'll see both the launch screen and the button. Don't forget to commit these changes to Git, but otherwise that's it for today's practical exercise. Well, it's been a lot. I'll try to summarize the things I covered today. I showed you Xcode, which is the most used IDE for working on iOS apps. From the developer's point of view, an app is a target in an Xcode project, but projects can contain other targets as well. Each target consists of certain files, such as the source code, UI, resources, and so on, and the files can be included in multiple targets. The app has a lifecycle, which starts at launch and ends at shutdown, and the changes in the app state are reported to the app delegate. When I taught a similar course at work, I used to give home assignments. Obviously, I can't assign you anything on YouTube, but if you have some time, play with the app installed on the simulator or a real device and look for more events which affect the app's lifecycle. For example, locking the device, stopping the app in Xcode, and so on. I'll leave a link to how you can run the app on a physical device in the description. You'll probably need a developer account, but you can create one for free. Also try launching the app on different devices and see how it looks. Remember that I added both the launch screen label and the button to the very center of the screen. But if you tried a larger or smaller device, you'd notice that they don't keep their relative positions. In the next episode, I'll focus on building the user interface and making it look consistent on screens of all sizes. That's it for today's video. Let me know in the comments what you think. Maybe you have some specific requests for the future episodes. I don't have a fixed release schedule yet, but I think I'll be making videos in this series every other week, while releasing the regular ones in between. If you're looking forward to the next episode, you should expect it in about 2 weeks from now. By the way, feel free to check out my regular videos, even if you don't have a lot of experience, because I often cover less technical and more fundamental things, such as why make apps accessible to everyone, including the people with disabilities. If you enjoyed this episode, please give it a like and subscribe to the Swift Bird. You can also support me and this channel with a single coffee or by becoming a regular member. You'll find the links in the description. Have a great time and never stop learning.